All right, today we are starting a new unit, Unit 6, and we're going to be looking at, throughout this unit, the relationships that exist in all triangles. So today we're going to start with 6.1, and we're going to be looking at perpendicular bisectors. So a perpendicular bisector is any line, segment, or ray that passes through the midpoint of a segment. That's the first key point, is it has to go through the midpoint, and it's perpendicular to the segment. So through the midpoint, and it's perpendicular. The perpendicular bisector theorem states that if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. And then we work backwards from that as well and say that the converse of that perpendicular bisector theorem says that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if you look here at an example of how this plays out, we have triangle EFH, and we are asked to find segment EF. Well, I know that segment EH has a point on it that is point G, and point G is the midpoint of segment EH because segment EG is congruent to segment HG. Now, I also know that there's a line that goes through segment G that forms a perpendicular angle with segment EH. So therefore, line FG is the perpendicular bisector of segment EH. All right, so since EF, then, if you look at EF and HF, because FG is the perpendicular bisector of EH, that means that point F is equidistant from point E as it is to point H. So therefore, that means that EF is equal to HF. That's the perpendicular bisector theorem at work. Now, we can substitute in what we know EF to be, which is 4a minus 15. And we can substitute in what we know HF to be, which is a plus 12. And then we can subtract from both sides to get 4a and make that 27. 4a minus a, so make that 3a, and add 15 to both sides to get 27. And then we divide both sides by 3 to get that a is 9. So EF is going to be equal to 4 times 9 minus 15. So substitute that 9 back in for a, and we get that EF is 21 units long. So next we're asked to find XY. So because WX is equal to WZ, you see they're both 25.3 units long, and WY is perpendicular to XZ. WY is the perpendicular bisector of XZ. And we would say that's because of the converse of the perpendicular bisector theorem. By the definition of segment bisector theorem, XY equals ZY, because it goes through the midpoint. Y is the midpoint. So because ZY equals 22.4, we can say that XY also equals 22.4. So those have to be congruent to each other. All right, so that's how we use perpendicular bisector theorem. And what's cool about perpendicular bisector theorem is that we have lots of perpendicular bisectors in a triangle. So when 3 or more lines intersect at a common point, the lines are called concurrent lines. And the point of intersection is called the point of concurrency. So since a triangle has 3 sides, it also has 3 perpendicular bisectors. And these bisectors are concurrent lines because they have a point where they all intersect. The point of concurrency of the perpendicular bisectors of the sides of a triangle is called the circumcenter of the triangle. The circumcenter. Okay, so the circumcenter theorem tells us that the perpendicular bisectors of a triangle intersect at a point called the circumcenter that is equidistant from the vertices of the triangle. So if P is the circumcenter of ABC, then, therefore, PB would be congruent to PA, which would be congruent to PC. And the lengths would all be the same. So in this image, we could say that that is congruent to that, which is congruent to that. So all of the lines going from the vertex to the circumcenter P are all equal. That is because the word circumcenter is based on the fact that if we were to draw a triangle around this, draw a circle around this triangle where all the vertices of the triangle were on the edge of the circle, each of those lines going from the circumcenter to the vertices would be the radius. So that's why it's called the circumcenter, because the center of that circle would be the circumcenter. All right, so that's where we get that word from. So we're asked to use the circumcenter theorem and to find BF if D is the circumcenter of ABC. We're told some useful information here. We're told that AC is equal to 9, so let's go ahead and label AC as 9 units long. DE is 1.83 units, so I'm going to write that in here, 1.83, and DF is 1.53. Okay. Now, D is the circumcenter of ABC, so DE, DF, and DG are the perpendicular bisectors of the triangle. And because DE bisects AC, that means EC is equal to half of AC. So EC is equal to half of 9, or we could say it's equal to 4.5. So we're going to use the Pythagorean theorem to find DC. So the Pythagorean theorem, remember, is a squared plus b squared equals c squared. In other words, the sum of the sides squared is equal to the hypotenuse squared. So in this right triangle here, that has a leg length of 4.5 and a leg length of 1.83, we're asked to find side DC, which is the hypotenuse. So if I did 4.5 squared plus 1.83 squared, it would equal DC squared. So 4.5 squared is 20.25. 1.83 squared is 3.3489. So if I added both of those things together, I get 23.5989. And that equals DC squared. Well, I don't want DC squared, I just want DC. So I got to take the square root of DC squared. So I get DC is equal to the square root of 23.589, which is 4.8. We're going to round up to 4.86. So by the circumcenter theorem, DC is equal to DB. All right, so because those are those lines that extend from the circumcenter to the vertex. So if DC is 4.86 or thereabouts, then so is DB. So because DB equals 4.86 and DF equals 1.53, we can use the Pythagorean theorem to find BF, which is what we're trying to do. So let's go ahead and label BD as 4.86. So I have one side of the triangle is 1.53. The other side I don't know, which is BF, is equal to the hypotenuse, which is 4.86 squared. So I'm going to square the 1.53, and I get 2.3409. square the 4.86, get 23.6196. So I want to get BF squared by itself, so I need to subtract 2.3409 off both sides. Get 21.2787. And then I take the square root of both sides. So take the square root of that number, 21.2787, to get 4.6, approximately 4.61, we can just say. And that is the side length of BF. All right, so one more example. We're asked to find SV if S is the circumcenter of QPR. We're told that QR is equal to 7.79, and that's already labeled for you. And we're told that PS is 4.25. Well, since PS is 4.25, that means I also know that RS is 4.25 and QS is 4.25. So if I can figure out what VR is or VQ by just taking that 7.79 and dividing by 2, so 7.79 divided by 2, that's 3.895. So that means that's 3.895 and that's 3.895. So 3.895 squared plus SV squared is equal to 4.25 squared. So 3.895 squared is 15.17. And 4.25 squared is 18.06. So if I subtract 15.17 off both sides, I get 2.89. And then if I take the square root now of both sides, I get SV is equal to 1.7. So SV is equal to 1.7. All right, well, that does it for today's notes. If you have any questions, please shoot me a Canvas message or an email, and I'll get back to you as soon as I can. Have a great day.